Good morning, sir. I am Rosaline M. Pripose, and the topic that I will going to report is all about testing of soil and water for drainage. So, natakal naman na sa mga previous report yung about sa drainage, which is ito yung paagusan or system or process by which water or other liquids are drained from a place. Ito yung paraan ng pag-alis ng labis na tubig or excess water. At sa pagpapatayo or pagpapagawa nga ng drainage system is magkakandak muna tayo ng mga testing of soil and water para ma-determine natin kung gaano kaangkop yung lugar para sa pagpapatayuan ng drainage system. So, meron tayong soil evaluation. Soil is an important part of on-site individual sewage treatment or OSST system dahil ginagamot at itinatapon nito ang effluent or yung mga liquid waste or sewage ng septic tank. Sinasabi din na ang soil sa mga drainage field ay dapat na epektibong salain ng liquid waste or sewage and hindi nito inaalaw yung inhibiting consolidation or swelling of the soil. For example kasi, ang mga dense clay soils, ang properties ng mga dense clay soils ay rough, thick, and heavy. At hindi nila kayang i-absorb or hindi nila kayang salain or i-filter ang mga liquid waste properly. Kaya, dense clay soils are considered an acceptable soil for an OSSC system with an absorption drainage field. Ang definition ng soil evaluation is an assessment of subsurface soil conditions at a specific site that is conducted under the supervision of a professional engineer or professional geologist. So sa soil evaluation, chinecheck dito if the soil is suitable for construction ng drainage system. Tinetest din dito ang composition at texture ng lupa to determine its structural stability. So, in evaluating the soil, dito nga chinecheck kung yung soil ba na pagpapatayuan ng drainage field is angkop. Sa pagsasagawa ng soil evaluation, nagbobore or naghuhukay tayo ng butas na may lalim na 6 to 8 feet doon sa site na pagkakandakan ng mga soil testing. Dito i-examine at susuriin ang profile ng lupa kung meron bang limiting layer ng soil or bedrock layer na humahadlang sa wastong pagsipsip at pagsasala o pag-filter ng wastewater doon sa nakaplanong paglalagyan ng drainage system. So, sa soil evaluation, required daw yung minimum depth of unsaturated soil beneath the plant soil absorption system before it reaches a limiting layer para ma-restore niya yung wastewater before it reaches a limiting layer. Yung limiting layer na tinatawag may be an impervious soil layer, bedrock, or a high water table. Kapag yung limiting layer daw is within 5 to 7 feet of the surface, depending on local regulations, the site is not suitable for an absorption drainage field system. If a limiting layer is located naman within 2 feet or 0.6 meter of the surface, the site is not suitable naman for a mound system. At yung iba pang conditions na nagre-restrict sa paggamit ng drainage field system include a ground slope of greater than 30% or 30 feet drop in 100 feet, 30 meter in 100 meter. Adverse effects on adjoining property and a proposed location in a 100-year flood plain. Sinasabi that soils can vary significantly from site to site and even at a single building site. And yung accurate assessment daw ng soil sa building site ay kailangan to ensure na hindi mag-fail ang OSST system. Yung lalim ng soil and yung kung gaano ito kabilis mag-absorb ng water ay ginagamit to determine the suitability of the disposal area for a septic system. So this information, coupled with the estimated wastewater produced by the building or buildings, is used to determine the size of the soil absorption system. So another test for the soil is what we call soil percolation test. A soil percolation test is a subsurface soil test at a depth of a proposed absorption system to determine the water absorption capability of the soil. Sa soil percolation test, dinedetermine dito yung water absorption rate ng soil in preparation for the building of a septic drain field or infiltration basin. Mahalaga ito for initial inspection before tayo mag-install ng new drainage, lalo na sa mga soakway. Dahil ang result dito will tell kung gaano ba ka-efficient yung surrounding soil na mag-absorb ng water. Dito sa soil percolation test is isinasagawa siya sa pamamagitan din ng paghuhukay ng series of test holes at the site under consideration and observing water seepage rates in holes placed throughout the intended area of the drainage field. So yung bawat butas is pre-soak with water, nilalagyan ng tubig in an attempt to saturate the soil. So yung water seepage rate is then measured in each hole and reported as the number of minutes it takes an inch of water to soak into the soil. Dito nga sa soil percolation test, nilalagyan ng water yung bawat butas and ino-observe yung water seepage rate or yung velocity or yung kung gaano kabilis ang pagtagos ng tubig. May mga soils kasi na hindi kayang mag-absorb or mag-filter ng liquid waste properly. Therefore, they are considered unacceptable soils. Kapag sa gravel, mabilis na dumadaloy yung tubig at hindi nito kayang gawin ang treatment bago maabot ng wastewater ang limiting zone or limiting layer. Also, tulad ng nabanggit ko kanina, na ang dense clay soils ay nag-a-accept ng water sa mabagal na paraan and merong difficulty treating ng wastewater from a building na nagkukos ng system to become overloaded. A soil percolation test is required for any system dependent on soil absorption for effluent disposal. So, ang percolation testing procedures ay established or nire-recognized or may authorized ng governmental health entity, commonly a municipal or state office of health. So, typically, this test must be conducted under the supervision of a professional engineer or professional geologist. Sinasagawa ito under the supervision or merong guide ng professional engineer or ng professional geologist. So, figure 15.6 is a trench for a percolation test. So, merong mga label sa pagsasagawa ng test doon sa area, label nung parang muka nung sa procedure, and yung mga gagamitin, and yung sa may soil. Merong reference elevation for measuring, merong measuring stick, pinapakita yung undisturbed soil, yung hole or yung butas na bored in earth, yung water level at start of test, yung water level at end of test, gravel in bottom of hole, and yung depth of proposed drain field. So, figure 15.7 is a typical soil percolation test procedure. Ito yung procedure sa pagsasagawa ng soil percolation test. Una, number and location. So, kailangan merong alam natin yung number ng bawat butas na kailangang hukayan and yung location ng pagsasagawaan natin ng percolation test. Dapat daw na 6 or more test ang kailangang isagawa sa mga magkakahiwalay na holes sa lupa na may pantay na espasyo sa area site. Number 2 is the results. Ang mga percolation holes sa area site ay dapat na gamitin daw sa pag-calculate ng arithmetic average of percolation rate. Number 3, types of hole. Yun yung mga uri ng hole. Yung mga butas na may parehong diameter na 6 to 10 inches ay huhukayin based sa mga sumusunod. A. Ang limiting zone ay 60 inches o higit pa mula sa ibabaw ng mineral soil. B. Hanggang sa lalim na 20 inches kung ang limiting zone ay natukoy bilang seasonal high water table. C. Hanggang sa lalim na 8 inches above the limiting zone or 20 inches or less kapag ang limiting zone ay identified as rock with open joints or with fractures or solution channels. Number 4 is preparation. Number 5, procedure for pre-soaking. So, yung letter A is initial pre-soak na ang unang pagbabad o pagbasa ng tubig sa butas ay dapat may minimum na lalim na 12 inches over the gravel at kayang tumagal ng 8 to 24 hours bago ang percolation test. Letter B is the final pre-soak. Number 6 is the determination of measurement interval. The drop in the water level during the last 30 minutes of the final pre-soaking period shall be applied to the following standard to determine the time interval between readings for each percolation hole. A. If water remains in the hole, the interval for readings during the percolation test shall be 30 minutes. B. If no water remains in the hole, the interval for readings during the percolation test may be reduced to 10 minutes. So last is the measurement, yung pagsusukat. After the final pre-soaking period, water in the hole shall again be adjusted to approximately 6 inches over the gravel and readjusted when necessary after each reading. So A, yung measurement ng water level sa bawat percolation hole ay gagawin from a fixed reference point at i-continue based sa time interval na na-discuss sa paragraph 6 hanggang makumpleto ang 8 readings or hanggang ma-obtain ang stabilized rate of drop kahit alin sa mga holes o butas na mag-occur. Ang stabilized rate of drop na tinatawag ay yung difference of 1/4 or less of drop sa pagitan ng pinakamataas and pinakamababang readings sa loob ng 4 na magkakasunod na readings. B. The drop that occurs in the final period in percolation test holes expressed as minutes per inch shall be used to calculate the arithmetic average percolation rate. And letter C. When the rate of drop in a percolation test is too slow to obtain a measurable rate, the rate of 240 minutes per inch shall be assigned to that hole for use in calculating the arithmetic average percolation rate. The absorption area may be placed over holes with no measurable rate when the average percolation rate for the proposed absorption area is within the limits established in Table A. So as a conclusion sa procedures, kapag ang percolation test hole daw ay dry or tuyo at the end of 10-minute testing interval, ang butas or hole na yon ay hindi gagamitin sa calculation of the arithmetic average percolation rate. Kapag naman 1/3 or more ng butas ang natuyo at the end of 10 minutes interval, yung proposed absorption area ay maaaring hindi idisenyo o i-install sa mga butas na ito maliban kung matukoy ng local agency na isang anomalya ang nagdulot ng mabilis na rate ng percolation at ang retest ay within the acceptable percolation area limits. If walang anomalyang nadidiscover or madidiscover, the local agency may accept the percolation test results from the remaining holes. Kung ang mga result ay pupunan ng mga resulta ng karagdagang pagsusuri sa percolation na isinagawa sa labas ng lugar kung saan natagpuan ang mga tuyong butas ng percolation. Next, another test is what we call the biological oxidation demand test, or in short, BOD test. Sa BOD test naman, mini-measure dito yung amount of dissolved oxygen organisms are likely to need to degrade waste in wastewater. So, napakahalaga ng test na to for evaluating both how much treatment wastewater is likely to require and the potential effect that it can have on receiving waters. Sa BOD test, dito nga mini-measure yung dami ng oxygen na kinakailangan upang alisin ang waste dun sa wastewater. At sa pag-perform ng BOD test, inilalagay ang wastewater samples sa BOD bottles at inihahalo o pinapalabnaw ng nakaprepare na tubig na nagka-contain ng dissolved oxygen. So, the amount of dissolved oxygen dun sa diluted sample ay sinusukat, then pagkatapos, yung sample na yon is then stored sa constant temperature na 68 degree Fahrenheit or equivalent to 20 degrees Celsius. Common incubation periods are 5, 7, or 20 days, with 5 days the most common. At the end of the incubation period, the dissolved oxygen is measured again. The amount that was used is expressed in milligrams per liter, is an indication daw of wastewater strength. Another test is the coliform test. The coliform test determines whether wastewater has been adequately treated and whether water quality is suitable for drinking and recreation. Dahil nga very abundant sa human waste ang coliform bacteria, madaling ma-identify at malocate ang coliform bacteria sa wastewater kaysa sa mga viruses at other pathogens na nagkukos ng severe diseases. Therefore, ginagamit ang coliform bacteria as an indicator organisms for the presence of other and more serious pathogens. Some coliform are found in soil. Yung ibang coliform bacteria ay natatagpuan sa soil. So, tests for fecal coliform are considered the most reliable. However, tests for both total coliform and fecal coliform are commonly used. So, under the coliform test is meron tayong dalawang methods for determining the presence and density of coliform bacteria. The first one is what we call the membrane filter or MF technique which provides a direct count of colonies trapped and then cultured. Sa membrane filtration procedure, dito is ginagamit ang procedure na ito sa mga samples na mababa yung turbidity or yung pagkalabo and merong low bacteria counts. Sa pagsasagawa ng procedures, ibubuhos yung sample sa membrane filter. Tapos, yung bacteria sa sample ay mag-i-stay sa membrane filter. After nun, ipi-place yung membrane filter sa appropriate na nutrient medium. Then, i-incubate for 24 to 48 hours, and during the incubation, doon mag-grow ang bacteria and mag-form ng colonies. Pagkatapos ng incubation, i-examine yung membrane filter using microscope for bacteria colonies. So, yung pangalawang method is yung another method is the multiple tube fermentation method, or the MTFM, which provides an estimate of the most probable number, MPN, per 100 milliliters from the number of test tubes in which gas bubbles form after incubation. So, yung multiple tube fermentation technique ay nagko-compose siya ng three-stage na procedure na kung saan yung results ay ini-express sa kung ano ang may pinakalamang na numbers. Una is yung presumptive test. Sa presumptive test, ang mga tubes kung saan doon nilagay yung samples ay i-incubate for 24 hours at sinusuri para sa pag-create o pagbuo ng gas. Then, incubation is continued para sa mga tubes na walang pagbuo ng gas at muling susuriin after 48 hours. So, kapag may nabuong gas within 48 hours, iyon ay positive presumptive test. At kapag nag-positive ang presumptive test, magsasagawa tayo ng confirmed test. And the next stage or procedure is what we call the confirmed stage. Dito naman sa confirmed stage, ang mga fermentation tubes na nagko-contain ng brilliant green lactose bile broth ay i-inoculated with medium na nagpapakita ng positive result sa presumptive test. Ang mga tubes ay mag-undergo ulit ng incubation process for 48 hours at anumang pagbuo ng gas ay nag-i-indicate ng positive confirmed test. And the last stage is the completed test or stage, which is dito ang mga fermentation tubes at agar slants ay i-incubate sa loob ng 24 hours o sa loob ng 48 hours kung hindi makapag-create ng gas. Mula sa mga agar slants na tumutugma o nagko-correspond sa mga fermentation tubes kung saan nangyayari ang pagbuo ng gas ay examined using microscope yung mga samples. The formation of gas o yung pagbuo ng gas ay may tuturing na satisfactorily completed test na ipinapakita nito yung positive presence ng coliform bacteria sa sample. That's all. Thank you for listening and may God bless all of us.